All right, this is a test solving one of the static equilibrium problems. Number one, we see the situation here. We have T1, which is horizontal, and T2, which is on an angle. So we begin by drawing our free body diagram. So T2 is up on the angle, T2, so T2y, and T2x. And we know that's our theta, which is, of course, 50 degrees. Is it clear? MG is down and T1 is to the left. So it says find the values of T1 and T2 if the weight is 600 newtons, and we start with F net equals 0 newtons for our static equilibrium. So clearly you can see we have X and Y. So we'll begin with a net force statement for the X. So F net X would equal T1, and it's to the left, so negative T1 plus T2x. F net Y would equal negative mg, which of course is weight, so negative 600 newtons plus T2y. As per our vector components, T2, x is to the right, y is up, and there's our theta, T2. So T2y would be T2 times sine 50 degrees. Negative T1, of course, is to the left, and T2x would be T2 cos 50 degrees. Notice the condition for equilibrium has to hold, so 0 equals both. And clearly you can see we're going to isolate T1. So T1 equals T2 cos 50 degrees. We go to the other side here, and we are going to isolate T2. So we add the 600 newtons. So 600 equals T2 sine 50 degrees. Clearly we can see we can solve for T2. T2 equals 600 divided by sine 50. Yeah. So we can calculate that. Make sure your calculator is in degree mode. 600 divided by sine 50 is 783.24. Keep extra sig figs, of course. And as per our solving systems of equations, we're going to back solve for T1. So T1 equals 700.
Oh, that's good.
And 83.24 times cos 50. If you've kept your calculator values, you should be able to simply press multiply, as you can see here what I've done.
Yeah.
There's the 783.24. I'm just going to go times cos 50, and we get 503.459 or 46. So 503.46 newtons. And now, of course, sig figs, as you see up here, 600 is one significant digit. So T1 will equal 500 newtons, and T2, as we round to one sig fig, will equal 800 newtons. And yes, it's way off from 783, but that's how sig figs work, as you know. And we have our final answer.